Hi, folks. For section 3.7, which was all about linear transformations, I forgot to do a real world example for you, so I'm adding this on now. For modeling a real life situation, why you might have an original graph that needs to be transformed. If you imagine a cable company charging various customers for their cable services, the cost of those cable services for m months is represented by the original function written in black here, f. To attract new customers, you can imagine that the cable company might offer a discount by multiplying the monthly fee by a factor, a discount factor, c. The company could then add an installation fee to claw back a little bit of that money that they lost on the discount. And that installation fee would be K dollars. So the question is asking us to use this graph to find and interpret the values of C and of K. So I have my original f function here, f of m equals 60m. Well, what does that mean in the context of this problem? The total cost for m number of months is 60 times m. That must mean that a standard customer pays $60 per month. Okay, $60 per month. That's of the black line, the original function. Now, as our next step, if we look at function g takes that function f and multiplies it by a factor of c. And that c is the discount factor. And so what I have here, I don't know what my value of c is, but I can figure it out because I can see that my slope has changed. My slope has changed in this example. My slope went from a slope of 60, a rise of 60 for a run of 1, and now I have a rise of 60 for a run of 2. I have a rise of 60 for a run of 2. That means the slope is now 30. And I can see here that for a run of 1, my x value is in fact 30. Well, 30 isn't my value for C, but C times 60 gives me 30. So what must my value of C be? Well, to get C all by itself on one side of the equation, I need to divide both sides by 60, and I end up with C equals 1/2. So C is my discount factor. My value of C is 1/2, and that means our customers get half off the regular monthly fee. Regular monthly fee compared to normal customers who have to pay $60 per month. If I then look at the red function here, h of m takes my g of m function, which I just discussed, where c equals 1/2, and I add a value k to it. So remember, with y equals mx plus b, that extra addition factor gives us our y-intercept. So my line isn't the blue line anymore. My blue line has been bumped up here to where the y-intercept is 40. So my value for k, the value for my y-intercept, must be $40. And that $40 represents the installation fee for new customers.